Good morning. My name is Leon Hall with Raypak, Senior Service Technician here for 13 years. I'd like to introduce you to our PR 406 AENC. This is a Raypak atmospheric heater. First thing you'll notice, your gas drain here coming in, your Honeywell gas valve, inlet tap for your dynamic and static pressure, outlet tap here located for your manifold pressure. On the left side, you'll find the opening for your gas valve coming in. On the right side, we have our inlet and outlet header. At this point, we have the unitherm governor. Take this unit off, and unitherm governor resides back in here on the header. This here is a port for a pressure relief valve. And within the unit, you have, in the back side here, the bypass spring. You have 4 different units. First of all, you have your sensor with a 3-wire. The next is your pressure switch. It's in and out on the pressure switch. And then you have your high limit 1 and high limit 2. That's the whole safety harness for this particular portion of the heater. This is your non-resettable rollout fuse. Gets too hot out there, that blows out, and you have to replace the unit. Okay, the rollout switch that we mentioned, we call it a rollout switch, and it is designated on the panel up in here as rollout, but in the parts manual it would be called a fusible link. Looking on the inside, you'll find our PC board. This is the membrane switch connector. You have your 3-wire sensor. You have your remote switch, your power. Back in this section, you'll have this large connector, which is your safety chain. You'll have this 4-pin connector here, which is your gas valve. Here you'll have your high tension lead for your pilot. Here is your advanced technology transformer for your pilot. Here you'll have your input voltage to your rocker switch or your standby switch, and your output voltage, which goes into your board. This is the wiring diagram for the 406 heater, just above or behind the PC board. On the front of our heater, you'll notice our bezel right here, a rocker switch, which is our standby or 24-volt power switch. By turning this on, it illuminates your LCD. Your LCD will first give you a version, in this case it's a 1.03. You'll have a pool or spa set temperature on the top, and the actual water temperature of the water coming in on the bottom. By hitting your mode button, we will go from, in this case, off, to spa set, to off again, and back to pool. In this case, our set temperature is above our water temperature. We are now sparking. All of our safeties are met. However, if we have a problem with our high limit, to simulate that problem, we removed the high limit 2. This is your high limit 2. Also, to simulate your high limit 1, this is your high limit 1. It is now open, and that screen will show up high limit 1. This is your flow or pressure switch. I had a jumper to show normal operation and opened it to show it was bad. So that is your 3 safeties over here. Okay, this here is your rollout switch or your thermal fuse. This is going to be showing your last safety. Okay, the sensor open, of course, would be a break in the line. This is your sensor. To show that screen, I just pulled the sensor lead off. But you can see this in the field, especially if the installer has worked on your remote. A lot of times when he drops this panel down, it will pull this sensor wire off, and you will get that sensor open. So don't call in trouble call right away, pop this open, take a look and see if that just pulled off the heater. Looking at the top of the bezel, you'll notice model and serial numbers. If you have to call in for service or speak to a technician in field, you'll want to give him the model number. In this case, as I said, it's a PR 406 AENC. The serial number up here, the first 4 letters or numbers are very important. The 1306 is June of 2013. This is your draft hood. We're symbolizing a inside application here. Inside, you'll have to have this. We have it in here because we are in an enclosure. This is very critical. It cannot be modified. The J dimension, which is from the bottom of the draft hood to the top of the heater, has to remain constant per the model number. Welcome back. We've already gone over the 406 heater, some of the finer points. We'd like to look now at the installations. What you're seeing right now, what we're going to be looking at is the gas train. If you notice right down here, you'll have your incoming gas supply, a 3/4 pipe leading over to the gas valve. I've already got my manometer hooked up to the gas valve. This first test port is for dynamic and static pressure. I've also got a secondary manometer hooked up. You'll notice that is on the right side of the valve. That is for the manifold pressure. This is not a normal installation you'll find in the field. This is for our BTU room only. But if you notice on the left side of the heater, that's just a straight 90 going into the heater. It does not have a sediment trap. A sediment trap is mandated by the National Fuel Gas Code. Sediment trap is a 3/4 T that lies vertically. Your gas will enter the top of the T, go past the manifold and toward a 6-inch nipple, approximately 6-inch, with a cap on it. That is a sediment trap. Again, that orientation is mandated by the National Fuel Gas Code. It states that the gas has to change direction as it goes into the valve. If you notice right here, we've hooked up a water supply right now. We're going to simulate the actual firing off in field for our heater. We've got an inlet and an outlet water. We've got our gas set up to read our gas pressure, both dynamic and static, as well as manifold. Our manifold pressure will change when the valve opens and it will displace the water in the column. So let's just see how this unit will operate. First of all, I will say that we have a defective regulator here, so we're going to see what you don't want to see in the field. Again, you want about 10.5 inches water column maximum. You want to stay above 7 inches of water column at all times if possible. And you want, in this particular model, 4 inches of water column on the manifold. All right, let's go ahead and turn it on. It's going to come up with revision 1.03. And since we're now calling for more temperature than what we have, it's going to light. Just rectified the pilot. If you notice, our supply, 5.7 inches water column, way too low. You don't want to see this in the field. You want to stay above that 7 inches water column. Why? Because it will affect your manifold pressure. We have 3.7 inches of water column. This pressure here is not enough to drive this valve to a full 4 inches of water column. What's the problem? The problem's in the regulator. If you have this problem, call your gas company, have them come out here, check and or replace that meter and or the regulator. Okay, first of all, we have a problem and nothing's working on our heater. So what are we going to look for? There's no power into the heater for some reason. Let's check the power first. If you notice right here, we're hooked up with a black, a white, and a green, which is denoting 120 volts. So I don't know if we have any power coming in or not. You can check by going through the wire nut, which is what I normally do, but right here in the lab, we have the benefit of going right into this connector and checking our voltage. It says we have 115 volts. We have no display, but we do have that. Let's go ahead and check next what happens. We have our power going through our transformer, from our transformer to the switch, from the switch into the board. So we're going to take a look at our board next. 4 screws, 2 on each side. Panel flips right down. And look at what we find. Somebody forgot to plug it in. Well, let's be sure our rocker switch is in the off position, and we'll plug it back in. Let's see if we have any power. Look at that. We now have power to the unit. Now we're having issues here. If you notice, it's still sparking. It's not coming on. So we want to check to see what's going on with our pilot. Let's check to see if we got any voltage down to the pilot first. Take the red wire off of your valve. That is your pilot wire. And I'm going to hook one lead into this red, which is the pilot. Let's just check and see if we have potential down there. Potential is voltage. You can do that at any point that's a ground. You can check your potential. It says I have 27.4 volts. Okay. Does that mean I have a complete circuit? No, it does not. A complete circuit will be 24 volts from the red to the yellow. Let's check and see if I have a red to the yellow. All right, I do have 27 volts. So that means I've got power to the valve. Why is it not sparking? Or why is it not lighting? Well, in this case, it's very easy to check. Number one, I haven't got the gas valve turned on. Very simple. Happens every time I go out to a field, I'll find something like that. Not every time, but quite often. All right, so we check, we know we have power going into the pilot. If you have power to the pilot, it means board is okay. Probably need to replace that valve. If you do not have power, let's find out why. Again, on our circuit board, we want to check the circuit board to see whether or not we have power going out from the MVPV plug. And how do we want to check that? Up in here you'll see we have a purple with a black stripe, a yellow, and a red with a black stripe. The red with the black stripe is your pilot valve. The yellow is your common. I'm going to plug into the yellow. Basically what we've done is we've checked the power at the valve to determine whether or not the valve is operational or not. We had power to the valve. We probably had either a bad pilot or a bad valve. But if we come up here, let's say we have no power down there. We come up here to this plug. We check the red to the yellow. If we have power there, it would probably indicate we have a bad harness. If we have no power up here, it would more than likely indicate we have a bad PC board. In that case, you just have to replace the board. If you have a problem with your main valve, which is the violet and black, the same scenario would apply. Check at the valve, check at the connection, and check your board. All right, one other thing on our board. We have our remote, and if you have a customer call that has a problem with the remote, you want to be able to dissect it as quickly as possible. First of all, anytime you handle our board, we want to put on a grounding strap. This will take the static that's in your body, and it will discharge it to ground, so you can now safely handle the board. Any PC board, ours or anybody else's, is highly susceptible to static electricity. On our board, we have a remote plug. Remote plug has 3 wires. A blue, which is power out from our PC board, and then we have an orange with black trace and a black with orange trace. The orange with black trace is a signal to our board to turn it on in the spa location. The black with the orange trace is a signal to our board to turn it on in the pool location. In the old heaters, we used to have the power going out, and we'd have these 2 wires tied together to the wire coming back. We no longer do that. If you do that, you will have an error code. So to check the board, very simple to do. First of all, let's see whether the heater will operate or not. We're going to take this and we're going to go to our panel, and by depressing the up and the down arrow and holding that for about 5 seconds, we're going to go out of the remote mode. Let's just test that. First of all, I'm going to put it in the off position, and I'm going to hold the up and the down arrow for 5 seconds, and you will notice it is now in remote. So now you want to take it out of that remote to test it. We don't know if the heater's at fault or the remote is. What I do, I go to the heater, I do the same thing. Up and down arrow, you hold those in, and it will go out of the remote, and it will say off. So now it's a standalone heater. Now if I go to the mode, it's going to run. If you're in remote and try to hit the mode, it will not operate. So now we are out of the remote. We can check. Is the heater operating? If it does not operate, you got a problem with the board or a safety or whatever. If it does operate, you don't have a problem with the board. You have a problem with the remote. How does the remote work? Very simple. You have a blue wire, which is 28 volts, going over to the remote, and the power comes back to either the orange and black or the black with orange. If it comes back, that 24 volts, 28 volts, we call it a 24-volt circuit. If it comes back to the plug, you have a complete circuit, you're fine. The remote is working. If, however, the remote is in a demand for heat and you do not have power coming back to the orange and black or black-orange, you have a defective remote. So it's very easy to find out. If you want to check it in a remote operation, simply take the remote off of the blue, and let's say it's the orange and black. Plug this back in. Wire nut the blue and the orange together, and the heater should turn on in the remote spa location. Very easy to isolate that remote. We're back again looking at the 406, and we're going to try to go through a little bit of the multimeter usage and troubleshooting at the same time. You get a call to a customer and they say they have no display, the heater's not working. You go out there, brand new heater, you take a look, and sure enough, there's nothing going on. What are we going to do? We've got to check the power, okay? First of all, I want to take this cover off and just see if when they installed it, maybe they pulled the plug off. Well, they didn't. It's still on there, so let's get our multimeter out, put it on volts AC, and let's just check and see what we've got. We'll go from the blue to the yellow, and voila, we have got 6 millivolts. We do not have voltage. So we want to check and find out where we're dropping our voltage at. Looking over here, we have a black, a white, and a green going in. The red is capped off. This is a 120 volt hookup, so we're going to check for 120 volt. Okay, we're on AC voltage with our meter, and I'm going to hook one side of the meter, the black lead. Of course, on AC it makes no difference, but we'll hook the black lead to ground, and the reason I'm doing this is so I can have 2 hands free to work. I want to check and see what kind of voltage I have coming into the heater. It says we have 120. If I take this black lead, I can push right in through the socket here, or the wire nut, and hopefully we should see voltage. We have 113 volts coming in. This means what? We have a bad transformer, correct? That's the normal thought. Once a man has checked this like this, he's going to open this up and he's going to change the transformer. Is the transformer bad? Not necessarily. We've checked and we found we have potential. Potential is another word for voltage. We do not have a complete circuit, however. We failed to check one other thing. Instead of checking the ground, whenever you check for a complete circuit, you want to check the circuit itself. In this case, your black, and this is a little more difficult to do. Oh, there we go, to the white. We have no voltage, black to white. If you notice, we're stripped off. We're simulating a break in the common line. Without a break in the common line, we have voltage to ground, we have no circuit. We have an incomplete or an open circuit. Okay, we found out where the installer failed to strip this wire off, and that could also be simulated, or could simulate, I should say, a break in the wire somewhere between here and the transformer. Okay, we've corrected the situation here. Now we've got the common connected. We did have potential. Now let's see if we have a circuit. We turn it on and now we have a light. We now have a complete circuit going to our unit. The point is, instead of being a parts changer, you'd be a diagnostician and you check a complete circuit rather than potential. Potential is another word for voltage. Complete circuit is 2 points. One is the common, the other is the hot. In DC, it would be a negative and a positive. Okay, back on the 406, we've got the gas train off. Everything's disconnected now. What we're going to do is we're going to go through taking out the burner tray itself. First of all, the pilot right here. Let's just take that out. There's one screw up on the top. Holds the wire in. And there's one grounding screw down here, which holds in the pilot. Take those both back out, and the pilot should just slide right out. If you notice on the back here of the pilot housing, or the bracket, another screw, and now we have fully accessed the pilot. You can take this off with a 7/16 wrench. Take that pilot right off. We're not going to go through that right now, but you can take it apart to take a look at the orifice to see if everything's working okay. You can actually have this lit outside the pilot as long as you have the main valve wire off of the valve. Very important. As soon as that main valve or the pilot rectifies, the main valve is energized. So if you want to take a look at it outside, be sure that that wire, purple black or violet black, is off of your gas valve. You can actually see that pilot right now work if the gas valve's hooked up. All right, moving right along, let's go ahead and take a look at the burner tray. We're going to take off the rest of the wires here, that being the common, and the pilot, and the ground wire. There's only about 4 screws you have to be aware of right here. First of all, the bracket off of the valve. This is to hold the bracket of the valve in place. 2 screws out of there. Bracket comes right off. Get the burner tray out. We've got 1 screw down this corner, 1 screw on the opposite corner. Take those out, and we're now fully accessible. Right now, if you have this pilot off, you can go ahead and take this out completely and do whatever work you need to on the heater. Very quick, very easy to do. Right now, it's a little bit easier to do than what you'll find in the field, because what you'll find in the field has been used. If there's a problem with it, you may have sooting, you may have rust back there, you may have a lot of burning. It makes it difficult to take these out at times, but with this atmospheric, they're pretty simple. To get this bad boy back in, slide it back in. One thing when you put these back together, if you notice I'm using a DeWalt, I'm going to set this on very, very light torque. I do not want to strip these screws out. So we'll get it back on here. There is this, as I said, there is a slot back there which will receive the bracket. Push it straight in. And when you put the grounding wire back on, be sure you use the appropriate grounding stud or machine screw. And there we have burner tray disassembly and assembly. Pretty quick, pretty easy. We finished up the atmospheric, or the 406 unit, and now we have what is in California a mandated piece of equipment. It's a low NOx heater. In this case, we have a 407. This is a PM, which means that it's a ream unit. A heater is a heater. It's got gas going in on a gas train. It goes to the gas valve. There's a few differences, however, in what we have looked at and what we have now. First of all, we have the same gas valve. It's the Honeywell. The differences in this unit, number one, this is a fan assist unit. It's got a combustion blower. Since it has a combustion blower, it has a plenum which captures that air and diverts it into our burners. Our burners are 50,000 BTU burners rather than the ribbon burners, which are 15,000. It's another difference. We have a blower, so therefore we have an air pressure switch. Anytime you have a blower, it has to be proved or interlocked to the boiler. This boiler will not work without this air pressure switch proving. The other difference is the pilot. We have what we call a Palladoro pilot down here, and I'll take that out so you can see it. The regular pilot will not work in this unit because of the air blowing the pilot out. To take this pilot out, it's a fairly simple job. 2 screws, one on each side, and of course there is your ever-present and absolutely mandatory grounding connection. And there we have the Palladoro pilot. We have a resettable rollout fuse rather than a fusible link. On the atmospheric PC board, it will come as such. It's ready to use. If you have to replace the PC board on this unit, you have a knockout tab up here you have to break out. That tells the unit, the board, that this unit is a low NOx unit, and it's waiting for a signal to come back on this white wire to carry the circuit to approve and to light. The valve on our low NOx heater, instead of a 4-inch water column, we're looking for a 3 to 3.1 inch water column on the manifold. The manifold 3.1 to 3. The inlet gas or the static and dynamic gas are the same. You have 10.5 to 7. In our atmospheric units, you have on the right side, you'll have your transformer for either 120, 230, or 240, not 208. This unit is even more critical. You have 230, 240, or 120. 208 will not turn that fan enough to give a proper air to make the switch. Sometimes you'll lose your switch. Only other thing is on this side, you have a ice cube relay that is used to operate the fan. Other than that, there is basically no difference. They both receive gas, they both receive air, and they both set up accordingly to, in this case, a low NOx. The other one we're not so worried about. This is Southern California, basically, and Texas. A few other places are getting it now, so we want you to know about it so you can look at it and repair the unit.